Alright guys, this should not be a long one today, so we'll see how long this will take. This is kind of review, except for we did not ever do quick graphs with point slope form. Hopefully when you see a problem like this, you recognize that this is point slope form. So when you have point slope form, just grab the point that's given and then follow the slope. Do not solve it for slope intercept form. You're going to get fractions, and then graphing it is a lot more difficult. That makes it more difficult for me to grade. Just follow what form you have. So when you have point slope form, all you do is figure out what the slope and the point is. For example, this is the slope. The point that's given is the opposite values. Remember, it's opposite of what is given. So the point is -3, -2. So all I do is plot that point, -3, -2, and follow my slope. My slope is a -5/3. That means I'm going to go down 5 and over 3. There's my new point. I could also go up 5 and over 3 this way. And there's my graph. Done. Didn't have to solve anything. All I did was grab my information from the equation. Alright, here's my slope. My point opposite of x is -6. The opposite of y is +4. So I'm going to graph -6, +4. And my slope is 3/2. So I'm going to go up 3 over 2. 1, 2, 3, 1, 2. 3, 1, 2. And you could also go down and to the left. Alright, and there are the dots. Connect them. And again, you could always pause and try the last one on your own. Pause now if you want to try it. Otherwise, I'm going to do it now. That's your slope. The point is -8, -3. I have a lot of negative points here for some reason. -8, -3 is my starting point. Again, -1/6, down 1 over 1, 2, 3, 4, 5, 6. Down 1, 1, 2, 3, 4, 5, 6. I could go one more all the way to the end. And then you try to connect the dots. Yeah, that was okay. And there's my graph. The key is make your points clear when you're graphing these on the quiz and or the test. Don't just make the line. I need to see where they are specifically going through, like what made you pick those points. Alright, so those are point slope form graphs. We didn't do those on the first quick graph lesson. We just brought them in now. Alright, so we have one word problem and that's it. But this again ties into coming up with a linear equation and understanding function notation and having one variable in terms of the other. Let's read it. At sea level, the speed of sound is linearly related to air temperature. Okay, so sound to temperature. If the air temperature is 25 degrees, the sound is at 340 meters per second. If the air temperature is at 10 degrees Celsius, sound will travel at 335 meters per second. Write an equation that models airspeed v. So first of all, I'm giving you letters in terms of temperature T. Secondly, I should say, if you get a problem that says models something in terms of something else, that means this is your y value. You can think of it as your y, and this is your x value or your independent variable, your input value. Okay? So when you're writing your points, our points are going to be t comma v, not v comma t. Because our equation at the end should say v equals something. Because I want v in terms of the temperature. So whenever you have a problem like this, we're doing linear equations here. This whole chapter is about linear equations. Well, you need points to get a slope and to go get an equation. Luckily, I give you 2 points. The first point I give you is the temperature is 25 degrees and the velocity of the air is 340. The other point I give you is that when the temperature drops to 10, the velocity drops to 335. So, let us find the slope. Again, I'm going to use my method of jumping. This goes down 15. This goes down 5. So my slope is equal to -5 over -15, or a +1/3. So now, I'm going to come up with my equation. I have, and you can use either point. I'm going to use 335 and 10 but you could use 340 and 25. I'm going to choose to use this one in my equation. They'll both come out with the same thing. So first off, I start with my velocity minus my velocity point is equal to the slope times my temperature minus my temperature point. That is point slope form. We always start there. Now we solve it. We do want, if I want an equation v in terms of t, I want slope intercept form. I don't want to do that yet. I need to first distribute. So you have 1/3 t minus 10/3. Then you add the 335 over, and you get, and I would prefer that you leave this in a fraction because then it's more accurate. So I get the equation v of t. I'm writing it in function notation now just so I know what my independent and dependent variable are, is 1/3 temperature plus 995 thirds. Okay? Now, just so you guys know, remember the slope is the same thing as rate of change when we're working with word problems. So you would say this slope here is the change in y over the change in x. So you would say that this is 1 meter per second for every 3 degrees Celsius it changes. Okay, so if it goes up 3 degrees Celsius, it'll go up 1 meter per second. That's what this is referring to, this slope. So if I ever ask you, what does this mean in real life, you have to tell me, oh, this is happening because of this. This is happening, these are the units, so give me a more specific answer. So here's my equation, or my function. Alright, so how fast is the airspeed at a temperature of 19? Well, we can just use function notation. I want to know the velocity when the temperature is 19. And you just plug that in. Also, guys, if you ever see me make a mistake and I don't correct it, please let me know the next day so I can correct it for future. Just thought of that. So you type that in. I mean, you can type that in directly. You can use function notation in the calculator. Any way you want to do that. But when you do that, you should get an answer of 338 meters per second. Exactly. So that's how you figure things out when you know what the temperature is. But what about if it's the opposite? I know the airspeed is 350. I want to now know what the temperature is. Now you can solve this by hand. Again, be careful with your fractions and using the calculator. But again, you can also use your graphing calculator. So I'm going to show you real quick what you can do with that. The key to this is to enter each side of the equation into y1 and y2. Notice how in my y1 right here I have 1/3 x plus 995 thirds. My other y has 350. Now, you graph this, but the problem is you might not see anything right away because if you think about what's going on here, you have points like 19 and 300 and stuff like that. So what you want to do is change your window to look and see where these things are hitting. Our x, or our temperature, probably goes from 0 to like 30. Let's go up to 30 and see what happens. My velocity, we can say 0, but it's not even, let's just say we're going from like 200 to 400 because we are dealing with values that are much bigger. Now when you graph it, you should see the lines, hopefully. There's one line, and there's the other one. Notice how they did not intersect yet, because that means that the x is actually bigger. So I'm going to go back to my window. I'm going to make my x like 60. I'm also going to shorten this up a bit. I'm going to just say this goes from 300 to 400. So I should get a more slanted line. And there is an intersection point now. Another thing you guys are going to learn on your calculator is how to find the intersection of two lines. Okay? All you do is, put them into y1 and y2. You hit second trace, and then you go down to 5, which is intersect. I'm just going to hit the button 5. And all you do is kind of move it over towards where you think the intersection is, and you have to hit enter 3 times because it wants you to figure the first line, second line, and then a guess. Alright, so I'm going to guess there. First curve is that, second curve is that. My guess is about there. The intersection is 55. So when the speed of the air is at 350 meters per second, the air temperature is at 55 degrees Celsius. So you can use your calculator to do that. You could have just solved this backwards also, but I can say that my T is equal to 55 degrees Celsius. Alright, so that is how, again, to come up with a function using for word problems using just data points. Again, nothing new. We use point-slope form to slope-intercept form. It's all about understanding and interpreting the problem that you are given. And you guys will be doing a lot of that in this honors class, so make sure that you guys read everything carefully and understand what we're looking for. Alright, that is it.